started in a moment. Yeah, good morning, friends. This is Durga from IT Varsity. Those who are joining on YouTube, today I'm streaming it to public so that you guys are aware of the quality of training we are going through. So this video will be accessible to everyone. So that being said, let me talk about today's agenda. Today we'll be primarily talking about challenges with RDBMS and how the solutions are coming with respect to those challenges using other alternatives than RDBMS, such as data warehousing appliances or big data, etc. And then we will see brief overview about NoSQL databases, and also we will do some hands-on stuff related to MongoDB. Okay, this is just to give a perspective that there are alternatives to RDBMS, and also there are alternative frameworks than SQL to query the tables, and that will give some idea about the other stuff than RDBMS and how to get data from there. So that being said, let us start with challenges with RDBMS. So I am hiding the slide for now. I will let you guys to talk about what could be the challenges with respect to RDBMS. Just go to the chart and type what do you think are the challenges with respect to RDBMS, especially from batch and offline data processing. Already there are few people from data warehousing background in this group, so you guys can actually talk about it. There are only 17 people joined today. I don't know why. Performance. Can you elaborate, Puru? What do you mean by performance? I am looking for. Yeah, those are all known things, but I want to get into few technical details. What are the reasons behind poor performance when it comes to batch and offline processing with respect to RDBMS? Also, what are the challenges, or what are the main reasons behind RDBMS is not very good at handling growth in data volume as part of batch and offline data processing? I want you to get into details and give me the technical aspects behind it. Yes, Shiva, it's just started. So we are just talking about RDBMS challenges. The question is, what are the typical challenges with respect to RDBMS in terms of batch and offline data processing? I want you to get into more technical details and give some insight from technical aspects. Don't bring MongoDB here, but the statement is correct. So the table structure is rigid. You have table name and then fixed number of columns with names and data types, and you cannot deviate from it when it comes to RDBMS. So this is one of the technical challenges with traditional RDBMS and also many other structured databases. It is not just RDBMS. Even if you think about data warehouse appliances or MPP technologies, all these technologies have the issue of rigid structure for your data. Yeah, so Vasu is a bit correct. Schema flexibility and horizontal scalable. I'm not here trying to compare with the NoSQL. Don't get into the comparison to NoSQL. Just to tell what are the challenges you can think about with respect to RDBMS alone. Yeah, so far we got only one answer, that is fixed structure for our tables and schema. Okay, so let me show you details here. What are those technical challenges? Yeah, so this is another one issue where partitioning data is not that straightforward with respect to RDBMS. That is this is one of the challenges. Okay. Yeah. Any other guesses? So let me absolutely. Shiva gave the right answer. Lot of rules before loading data in tables. I am looking for this answer. Okay. So let me explain. So I am actually going to the create table statement, which we have used for creating a table. So I am going to apex.oracle.com here. And that is the most apt answer than anything else when it comes to uh, talking about what is actually causing the performance issues while performing batch and offline data processing in RDBMS. That is applying the rules. Okay. So I will explain once I log in and once I generate a create table statement. That's what I'm getting into those details. So it will be clear in a moment, Vasu. So here, if you go to object browser, and if you look at the table structure, each and every column have a data type. Okay, and also there is a length and precision. It doesn't show here, but for each and every column in a database, apart from data type, there will be length and precision also. Example is order status. Order status cannot be more than 30 characters. On top of it, you can define check constraints. You have primary key constraint where for each and every insert, it has to check whether the primary key value exists in the table already or not. Okay, it has to check for null if the ID you are trying to insert is null or not, if it is a primary key field. If it is a child table to another table, in this case, order items is a child table to orders as well as product. So for each and every entry that is inserted into order items, it has to check whether there is a corresponding order ID in orders and whether there is a corresponding product ID in products, right? So that is another check. So all these rules applied with simple insert statement into a table. It's not just it will go and log a record in a database file sitting in the storage. It is not like that. As part of running that insert statement, it has to understand the schema of the table and it has to apply the schema on that record. Okay, this is one of the major limitation of RDBMS when it comes to dealing with high volume data. For individual records, it is a feature. Okay, in this case, order status cannot be 30. So whether you handle it from the application or not, when it comes to the database, it will throw an exception. It's a feature. Okay, and normalizing the tables and reducing the redundancy by defining primary key and foreign key constraints when it comes to regular use cases like transacting using the application, those are all features. But when it comes to batch processing, if you have to load hundreds of thousands of records in orders, for each and every record of those hundreds of thousands, it has to perform all those checks and it actually bring down the performance significantly. All those features which are relevant, highly relevant for mission critical transactional scenarios are becoming a bottleneck for offline and batch processing. Okay, so is it clear, Vasu? Yeah. So don't mix up NoSQL at this time. We are only talking about challenges with respect to RDBMS. That is one thing. Another important limitation of RDBMS for offline and batch processing is it need to make sure the integrity of a transaction. Okay, so you typically insert multiple records into multiple tables and everything has to be committed as one unit or rolled back as one unit so that we have consistent view of our data. So even transactions, to enforce those transactions, there will be a lot of overhead. Okay, whether you commit or not, internally to manage the transaction, it generates undo, redo, all those things, and every operation will be logged into log files, and it actually brings down the performance significantly if you are trying to do huge batch processing. So one is applying the rules, second one is managing the transactions. These two are the primary bottlenecks. And also with the modern databases, you can have multiple servers to process the data. Not everyone will get this, but those who are experienced, I am talking for them. So freshers, don't worry too much if you could not understand what I'm talking about. So in terms of databases like Oracle, we can create something called cluster. You can have multiple database instances supporting one set of data. It is built for performance. Okay, but as both the servers are working on the same set of data, there has to be something called global enqueue mechanism to make sure that each one of the nodes get a consistent view of the data. So that is another technical challenge for RDBMS to scale when you try to perform offline and batch processing. Okay, like that there are a number of issues, but these are key issues. Okay, so whenever CRUD operations happen, it has to perform constraint checks, data type checks, length and precision checks, overhead of maintaining transactions, overhead for maintaining consistency view of data between transactions, and expensive join operations. So sometimes if I want to, for example, we have retail DB. I hope everyone have done exercises I have given yesterday. One of the exercises is, I think, to get the revenue for each order or for each day or something, where you have to join two tables. There we are not applying any where condition. We are trying to process the entire data set. So whenever you try to process the entire data set or huge number of data sets from multiple tables, the joins become very, very expensive. Okay, and not only your query might be slow, but it can impact the um, core business for which the applications are built. For that reason, these expensive queries should never run in the transactional database which is supporting the application. Okay, for example, you build an application for the e-commerce platform where orders are being placed and all those things. If someone want to see the trends about how departments within the e-commerce platform is performing, or regions within the country, from which part of country most of the business is happening. These are all very important reports for top level management. But to get those reports, you have to churn data from multiple tables by doing expensive joins. When you run that for the report purpose, actual transactions might get impacted because these join operations can take huge amount of resources on the database server. When I say huge amount of resources, what are those resources? Can anyone guess? Anyone guess when I say joins? What is that? Memory, yes. Memory, CPU, correct. CPU, memory, and networking. These three are the resources which will be used extensively, and due to which your applications can become very slow. Okay. For that reason, we should never run expensive queries in the database when the applications are being run in business hours. Sometimes we do some batch processing offline in the midnight when the businesses are when the business activity is at its lowest level. Okay. Otherwise, in peak hours, there are strict SLAs in the companies that no one should run a query. If someone runs the query, which is very expensive, in the peak hours, they can get fired. It's as serious as that. Okay. Yeah, cache is nothing but memory or virtual memory. So CPU and memory is the most appropriate answer. That being said, how can we get the solutions for these challenges? We have to get the reports. So for example, I want to get how my business have performed last day, or from this month, first day to yesterday, and I can see the trend whether my business is performing at a consistent rate, or there are fluctuations, or if it is going down consistently. All these insights I have to see, and I have to see. So till yesterday, I have to see as quickly as possible. Once the yesterday's 24 hours are passed, so there will be SLA. So within couple of hours, someone have to churn huge amount of data to get these daily reports, week to day report, or month to day report, monthly reports, which means past 30 days reports, uh, yearly reports, etc. So it's not just one report. We have to run multiple reports to understand how the business is going. For those purposes, if we start running on RDBMS, it will not work. It can cost your job also. Okay, so how can we solve this problem? That's where the data warehousing concept came into picture. Data warehousing can be implemented using appliances like Teradata, Greenplum, Vertica, etc., or even Hadoop now. So there are many technologies which can serve the purpose of data warehousing. Okay, and what is the process to get data into data warehouse? We have to identify all the sources from which data has to be fetched into the data warehouse as per the report requirement, and then we have to create the tables, and we have to come up with a framework called ETL framework. ETL stands for extract, transform, and load. Okay, so that's where ETL comes into picture, and we typically have it downstream systems. It can be big data system, it can be data warehouse appliance such as Teradata, Greenplum, Vertica, or Redshift, or it can be anything. Okay, so from transactional based systems, every day after the midnight, the data will be fetched for that day into the data warehouse, and then as we get for every day, you over a period of time you will get all the past data in data warehouse. Hence, you can build queries whatever you want, irrespective of the performance of your report. Nothing will happen on the source database. So your source database is immune with respect to the side effects of running expensive queries. That is the purpose of data warehouse, and the process that is used to get the data into data warehouse is called as ETL: extract, transform, and load. Okay. Now comes data modeling in in data warehousing. How do we model our data in traditional RDBMS? We use normalization, and we create tables defining relationships, etc. And then we can actually means application will start loading data into those tables, and business happens as usual. But when it comes to data warehousing, okay, even though now the report requirements are running in data warehouse, still meeting that SLAs of running the report. It can be daily report, it can be monthly report, it can be 30 days report, it can be yearly report, it can be past 365 days report, it can be whatever report. Okay, the SLAs will be the executive management want to see this information as quickly as possible. Probably monthly report he want to see by 2nd or 3rd of next month. Daily report probably by 8 in the morning of the next day. Like that, there will be SLS. So if we actually create tables normalized in data warehouse, and if we try to generate reports on top of it, even though the reports will not have negative impacts on the source system, still there can be challenges that you don't meet the SLS for the executive management to see those reports. And it's very, very critical to meet the SLS, because you are dealing with the top level management in the company. To address this issue, instead of using the normalized data model, we use something called dimensional modeling. Okay, so the terms they use in case of dimensional modeling are facts, dimensions, measures, etc. I will get into those details at a later point in time. For now, I'm just touch pointing important terms in data warehousing, and you should be able to explore and understand more about these terms. Okay, first thing you need to understand is in data warehouse, we use dimensional models or dimensional modeling to create the tables, not the normalized data models. No CORDS rules, no normalization, first enough, second enough, third enough will be that important when it comes to data warehouse. Okay, so here we are using denormalized data models, and that there are two approaches to create the data model in data warehouse around facts, dimensions, and measures. Okay, what are those two models or two approaches? One is snowflake schema, and another one is star schema. Okay, so when it comes to difference between star schema and snowflake schema, the dimensions are more normalized in snowflake schema. I will explain what is a dimension, what is a float, what is a fact, and what is a measure probably after a while, and then it will be clear. We will come back to these terms several times in future, and I will try to explain. So don't worry too much about it, but do some homework and try to read it, and you can ask me questions whenever we were discussing about these terms in future. Okay, so I will document these things as part of the Kaizen also after this class, so that you have some points for your reference. But you have to know all these things. Denormalized data models using star schema and snowflake schema, and also there is something called Kimball methodology and Inmon methodology in data warehousing. You have to explore those also. Kimball methodology and Inmon methodology. And there is another term called data mart. So you should, so unless you understand what is data mart, you will not be able to distinguish between Kimball and Inmon methodology. So these are the terms which you should be focusing on. And then for the performance reasons, we typically pre-aggregate the data. So for example, if I want to compute a daily report, if you have daily reports for past, means if the data is pre-computed for every day, the performance will be much better, right? For example, if there are 1 million records per day, how many there are 1 million records for each day. Okay, and if you have, let's say, 5,000 products, you have 1 million records and 5,000 products, and you want to see how much revenue is generated by each product, or how many transactions have happened for each product. That means when I aggregate, I just have to see the revenue for each product. So there will be only 5,000 records. For each day, there can be only 5,000 records, which will compute revenue per product for that day. Like that, if I have to compute yearly report, I just have to process 365 multiplied by 5,000 records, if I have the pre-computed data stored somewhere. Otherwise, what I have to do, I have to process 365 million records. And it is quite obvious. You don't need to break your head. Processing 5,000 into 365 records to get a yearly, means daily report for 365 days is much faster than processing 365 million records. Okay, that's where these aggregated tables comes into picture. These are called as facts and measures at different granularity. And we will see that when we actually start exploring the examples as part of our future sessions. Okay, so when it comes to databases, like there seems to be some questions. I will come to it in a moment. When it comes to technologies like Teradata, Greenplum, Vertica, etc. Okay, Redshift, many other things. These are all data warehouse appliances. And I told these are workarounds for challenges with respect to RDBMS. But those who already have experience in those technologies, they might be seeing the data types and also the precision and all those things. There can be constraints also. But if you actually go to the documentation and read, all that information is just, all those constraints are just informational. Most of the times, these MPP databases especially Greenplum, Vertica, Redshift, etc., they don't enforce constraint. They are just informational, saying that you are getting data from somewhere falling in this criteria. That's it. They don't enforce constraint. So that's why they perform a lot better compared to Oracle when it comes to processing data in batches offline. Okay. So last point is very, very important. In many cases, constraints are informational. They are not strongly enforced. And the examples I know or I am aware of are Redshift doesn't enforce the constraints. It's a data warehouse database in Amazon. Greenplum, Vertica, Hive, which is a big data database which we'll be exploring in detail. All these things will not enforce constraints. Okay. So let me take these questions in the chat. No, Shiva, fact is actual raw data, and the measure is some numeric value. For example, if we see the order items data, I think I don't have data in this. So let me go to I'm getting into the lab and then logging into MySQL. Use retail DB, store tables. So you can see orders data and then order items data here. Okay. Now, when it comes to, I will just show a simple example about how the denormalization data model work. Okay. When it comes to denormalized data model, so in this case, you can see there is a date, right? There is a date and there is order item subtotal in order items. Orders have the date and order items have order item subtotal. If I have to get daily revenue, I have to join these two tables in the relational database. But when it comes to fact, this is how the table will be. So I will not be able to create the table, but I will just show the DDL command here. Create table, order revenue, fact. Okay, so it will have order date. It will not have order ID. Okay, if you want, you can store order ID also, but there is no need to store order ID anymore because this will be a denormalized table, which will have both order item details and order details together. As it is denormalized, there is no point in storing order ID. Okay, so you can have this like this order date, and let's say data type is date, and we only store whatever fields that are required for our report. If I want to get daily revenue of from orders and order items, I don't need any other field than date and order item subtotal, right? There's no need of anything else. If I want to compute revenue daily revenue for each product, then I have to have product name, order date, and revenue. Okay, so you need to understand the requirement. So what is the requirement? Get daily revenue for each product. So from that, daily revenue is the measure, which means revenue is the one which is used to compute the measure. Okay, so the fact table, we will have a key, and then we will have whatever fields that are required to compute the measures. In this case, our key is only date. Okay, nothing else, because we are only getting daily revenue. Daily revenue. If it is daily revenue per product, our key could be date and product name or product ID. It depends upon how you want to model and what you are looking in your report. Most likely it will be date and product name. Okay, so in this case, we are trying to get order revenue fact, and I will be using product name also. Okay, and let me define it as 200 characters, whatever it is. I'm just giving some hypothetical numbers. Okay. And then order item subtotal. Okay. So this is how a fact table will look like. It might have the raw transactional data for which means for each and every order item, it will get the corresponding order name, order date, and corresponding product name, and then it will store the details here. So this is called as lowest granular fact table. We are getting the raw data as is by just denormalizing the fields and storing it. So that's why it is called as lowest granular. So you can define fact table like this. But what will happen if you have 100 million order items in your dataset? This fact also will end up with 100 million records. And using this fact table, I can compute daily revenue. I can compute daily revenue for each product. I can compute both the reports. So typically, when we get the report requirements, we will try to consolidate and try to come up with a proper data model which can serve multiple requirements in one shot, multiple report requirements in one shot. So using this data, I can compute daily revenue and also daily revenue per product. Okay, but the side effect of storing data at lowest granular like this will be you will have 100 million, whatever number you see in order items, you will see here. But what if my lowest granular report is daily? Then I can consolidate the data by pre-aggregating for each day while storing into this table. Okay, so in this case, we are going a bit higher granular level. Instead of storing at a raw level, we are now pre-aggregating at daily level, because my report requirements, the lowest granularity is daily. Below that, I'm not interested. In each and every hour, how my business is performing, I'm not interested. In that scenario, we can create fact. The fact structure will be like this, but order item subtotal will be pre-aggregated based on order date and product name. Okay. Even if you pre-aggregate at order date and product name, if you want to get the daily report, you can group by order date and you can get the daily report. Okay. So this is how fact table look like, and order item subtotal is the field which can be used to compute the measures such as daily revenue or daily revenue per product. So revenue is the field which actually gets you the measure. And in this fact, order date and product name are keys. So this is fact table. And then what is dimension? I told you that when we say daily report, we might want to see weekly report beyond daily. We might want to see monthly report. We might want to see quarterly report. We might want to see yearly report, right? So using this data, we can compute all those things. Okay. But instead of storing order date here, we might we might store order date itself, but probably in a particular format like YYYYMMDD format. And if I want to get monthly report, I have to extract whatever information I need from order date, and I can compute monthly reports, right? It is possible. But if I want to see how my business is performing on Sundays, or how my business is performing on Fridays, how my business is performing on weekends versus weekdays, these are all very good insights. And we don't need to again compute. We can use the same data as long as we have a dimension called date dimension, in which table we will have the respective information. So for a given date, what is the day, whether it is a Sunday, Monday, for which month it belongs to, for which quarter it belongs to, for which year it belongs to. We can store all that information, and then we can join that with this fact table, and we can see the report. So that's where dimension comes into picture. Dimension is just metadata which drive your report requirement. Another dimension for this table is product. Product have categories and department also, right? So if I want to get the report at category level using this data, probably it's better to have a product dimension where our relationships between products, categories, and departments are defined. And using category, you can query the product name and using product name, you can get the report from this table, and you can aggregate, and you can perform. You need to perform join between dimension and fact, but in this case, the join will be very very little expensive compared to joining in original data. We will see practical examples on this, and it will start making more sense at the time. Don't worry too much about it if you could not digest the information, but just brainstorm a bit on facts, dimensions, measures, hierarchy, data mart, snowflake model, snowflake schema, star schema, all those things, Kimball methodology, Inman methodology, all those things. Okay, so that it will start making sense when we talk about these things as part of big data. What is that? No, this, so it will not be, you can create views also. There are so many concepts in this. Okay, it can be view, it can be physical table also. Okay, and sometimes so once the data is processed, we will be visualizing the data using reporting tools such as Tableau, Cognos, ClickView, etc. Okay, and those visualization tools have concept of cube. So even if your data mart is normalized as is in your source database, what these BI tools will do is they will cache the results of these expensive joins. Only first time it will take long time to generate the report. After that, it will be getting the report from the cached results. So there are multiple ways to address that issue. So it can be view, it can be a table where the data is pre-aggregated. It can be taken as part of the BI layer also. But with big data, you have to pre-process your data as much as possible and store it physically, not logically using views. Okay, so now let me take questions here. No, measure is just a term which is kind of a field within the table. It can be derived field, it can be actual field. So to answer Bala's question, so in this, in case of data warehousing, when we say denormalized data model, it doesn't mean that it's completely denormalized. Okay, it will be normalized up to an extent where we can get the best of the performance by reducing the number of tables in the join. We should avoid joining fact tables as much as possible because fact tables are tend to very big. Okay, but using dimensions and by defining normalization rules between dimensions and fact table, okay, you can actually reduce the redundancy of your data significantly. And by using pre-aggregation strategy, you will reduce the complexity and also overhead to perform the join. So when I say denormalized, it is not that it's completely denormalized. Okay. So Jitendra, I have connected to MySQL database. Bala, is it clear? Or do you have any question? We'll come back to this at a later point in time as well. So it will actually make a bit more sense. Yeah, that's what it will be normalized. It will be normalized, but not as normalized as in RDBMS. We don't apply standard first normal form, second normal form, third normal form rules in case of data warehousing. Okay. So in this case, you cannot identify a primary key unless I pre-aggregate to an extent. If it is a raw fact table for our transactional data, it's completely denormalized data. To get this, we have to join 3 tables: orders, order items, and products. Okay, and as we get the raw data into this, now we are eliminating 3 joins. So when I say denormalized, facts are typically denormalized, but we normalize certain keys to reduce the redundancy so that we can actually query the reports based on certain dimensions. Okay, So it will be clear by the time we complete the course. As part of the visualization, I will be touching up a few things, and you will understand where the dimension comes into picture and where the facts comes into picture. Why we have to normalize, or why we have to create a dimension and define a relationship between fact and dimension. So normalization applies between fact and dimension, and between the dimensions it's themselves. But fact itself is kind of a denormalized table. In this case, this fact table is denormalized table from orders, order items, and products. Okay. So it will fail because this doesn't have permissions, and also there is some syntax issue also. Okay, so that being said, now let's get into NoSQL, and we will see few details about MongoDB today. Probably we will continue next class as part of next class also, if we could not complete MongoDB today. And these solutions are primarily to deal with offline batch processing of our data. So now NoSQL databases. NoSQL stands for not only SQL. Examples for NoSQL are HBase, Cassandra, MongoDB. Typically, they are indexed and partitioned. Indexed by a key, and they are automatically partitioned. In MongoDB, it is not typical, but with Cassandra, HBase, and all, by default, it is the tables are indexed by a key, and the key is typically having some business context. Unlike RDBMS, where the keys are typically surrogate keys, where there is no business law context associated with them. When it comes to NoSQL databases, typically the key will have some business context. Okay, and data will be sorted by that key and also partitioned by that key, and works very well for scalability of simple tables or simple use cases. So let me give few examples, and let me tell you what type of problems NoSQL databases solve. Unlike RDBMS, NoSQL is not very good solution for implementing mission critical transaction based applications like e-commerce platforms, etc. NoSQL is not a good solution. And the reason why RDBMS is a good solution is they have a very robust and reliable restore and recovery mechanism with zero data loss. Okay, and it comes with a lot of overhead. That's the reason why in terms of transactional use cases, we typically use RDBMS only. There is no alternative for that, and Oracle is the market leader in that area. For all other use cases which are complementary, which are not mission critical, you can use NoSQL, and it scales very well. Okay, so let me show you few examples. I typically take Amazon's recommendation engine and LinkedIn endorsements as example for NoSQL. So if you go to LinkedIn, I'm going to my LinkedIn profile. If you go to my LinkedIn profile, and if you scroll down, there is something called endorsements, skills and endorsements, right? So what it is doing, it is giving a report of our endorsements. I have, so there's a limit of 50 technologies, and these are the technologies on which I am endorsed. Okay, you can see the number of endorsements for each technology here. So if you have to implement in RDBMS, how will you do that? Let's spend some time, 2-3 minutes I will give. Let's think about how will you implement this with RDBMS. Any guesses from online? I'm talking about data model. I want to implement this endorsement in RDBMS. How will I do that? So the question is, if I want to implement this endorsement, what is endorsement? People like you can endorse me, I can endorse you, okay, and that has to be preserved in a database. And whenever someone visits the profile, they should see the report. That is the requirement. So if you have to define the data model for these endorsements, how will you do that in RDBMS? I'm talking from RDBMS perspective. Don't think from NoSQL perspective. Just think from RDBMS perspective and tell me how will you create a data model for this simple application. No, I'm talking about RDBMS. So when it comes to facts and dimensions, they are typically for batch and offline processing. In this case, the use case is not batch and offline processing. What is the use case? If you endorse me, I should see immediately. It's not that I should see tomorrow. It's not daily report or weekly report. So there is no concept of facts and dimensions here. I'm not asking to design the application. I'm only asking to actually come up with the data model. Just give me the data model. So Jitendra, you are actually talking about the design for this. You are trying to give the solution design for the problem rather than coming up with the data model. Yeah. So Bala and Kumar are a bit relevant. Bala say that you have skill, endorsement, candidates, or relations or tables. Okay. So there, what he's saying is there need to be multiple tables. One can be skills, one can be endorsements, and one can be candidates. Yeah, go ahead. That's what I'm asking. How will you model using relational database? Kumar is also a bit relevant. We have to have normalized table and aggregate table. Okay, Bala is saying skill ID name. Yes. No, don't talk in terms of facts and dimensions here. Okay, just give me the typical standard RDBMS based data model. Okay, so let me tell. So as Bala have mentioned, there can be a table called skill, which has skill ID and name. Okay, and also he said there can be a table called endorsements, in which there will be endorsement ID and who and whom are who is endorsing whom and what is the skill he is endorsing on. So he will have skill ID over there, and then there need to be another table which will actually store the details about the individual. So what are the details we are capturing for a given individual? We are trying to get the name. Okay, sometimes it is also showing the titles of the people and also company. You can see here the report is saying endorsed by 8 of Durga's colleagues at Symphony Telica for data warehousing. So we have to have another table which will give the details about the guy so that we can generate this kind of report when someone visits the profile. So skill, endorsement, and the person. Person will have ID, name, photo, because it is also displaying photos, right? And many other details, company name, whatever it is. Okay, all this information has to be stored in multiple tables, and the relationships have to be defined. And from read perspective, we always see the report like this. We don't deal with individual endorsements. Most likely will be accepting or rejecting some of the endorsements. That's it. Other than that, you will not be interacting with endorsements directly. So if you use the relational data model, if someone visits my report, okay, and if you all of you guys endorsed me, at least I should see in a minute or two. I should not wait until tomorrow to see the endorsements. If it is like daily report or weekly report, the way we have spoken earlier, it makes sense to do batch and offline processing. But in this case, we cannot rely on batch and offline processing. The processing has to be done in real time. So let's say there is a normalized data model with three tables, and if someone visits my report based upon my ID, it has to go to endorsements table, get all the endorsements, go to endorses, the table which contain the details about the professionals, right? And get the picture, which company he's working for, and all those things. And then get all my endorsement, and we have to aggregate, and we have to provide as part of the visualization layer. All these things have to happen in real time. Whenever someone visits my profile, it has to happen. It is a overkill. There are three tables, and for each and every ID, for each and every request, it has to join three tables. And in my case, to get this report, it has to touch at least 8 to 9,000 records, because I have 50 skills, and each skill is, on average, I have more than 100 or 120 skills. If there are 120 endorsements, if there are 120 endorsements, they have to process 6,000 records. And LinkedIn is such a huge platform. If it have to happen for all the requests that are happening at a given point in time to get this report, the solution is not scalable. Hence, using normalized data model and using traditional RDBMS will not work, even though the use case is operational in nature or real time in nature. So the use case is not batch and offline processing. The use case is real time. Only thing is there are no transactions involved, which are mission critical. For example, if all of you endorsed me, even if I do not see some of your endorsements, no one is losing anything there. You will forget what you endorsed me on, and I will not be even know whether you endorsed me or not also. Okay, so it doesn't matter if some data is gone. Hence, we don't need to use expensive traditional RDBMSs. Instead, we can use databases like NoSQL. Okay. In terms of NoSQL, as some people mentioned, we will have two tables, one for raw data, one for aggregated data. And there has to be a model where data for several seconds is queued and applied in the aggregated table. It has to be real time. Okay. There needs to be a raw table where each and every endorsement will be there. And also there should be a table which stores the pre-aggregated. Okay. And this pre-aggregation should not happen for each and every record. The technology should be capable of, or the design should be capable of queuing up endorsements for multiple people and do as a batch. So typically they use 2 minutes or 1 minute. So probably my report might be 2 minute delayed. There is no harm with that. Instead of 1 day delay, 2 minute delay, there is no harm. I'm okay with that. Most of the professionals are okay, right? So there can be 2 minute delay, and instead of processing or pre-aggregating on each and every transaction happening in the application, we queue up for 2 minutes, and we actually store the data in a pre-aggregated table. And now, if someone visit my report, visit my profile, it just have to touch around 50 records from 6,000 records and doing a lot of aggregation. Now it has to only touch 50 records and generate this report. That's it, or even less, because the default report only shows three top skills and some details about those skills. I can pre-aggregate up to that level, and I can show those things immediately. Only when I click and expand for other things, probably it might have to do some more work. It all depends upon how you want to design. So this process of pre-aggregating the data at a very low frequency, at a very high frequent intervals, is called as streaming. So as one of the guys have suggested, streaming is the solution to get the data into the aggregated table, where data is pre-aggregated as much as possible, using which the reports will be displayed. And one of the technology for streaming is Kafka and Spark streaming. So we'll be covering those also. as we get into big data skills, big data related material. Okay. So that being said, for endorsements, the key can be my profile, my email ID, because email IDs are unique in LinkedIn. I always log in using email ID. So the key can be my email ID, and the value can be individual endorsement details for raw table, and for pre-aggregated table, the value can be whatever report we are seeing here. Okay, that is how the tables will be modeled in NoSQL. Okay, so now let us get into MongoDB. MongoDB is NoSQL database, and you can use MongoDB for use cases like this, recommendation engine of Amazon, etc. Okay, so that being said, as you guys have access to the lab, you can launch MongoDB by saying mongo --host gw01.idiversity.com. So this is the host on which MongoDB is installed. Okay, so I'm copy pasting in the chat. It will not ask for the username, password, etc. Okay, you can run this, and now it has launched the Mongo shell for you. Okay, now when it comes to MySQL or Oracle, in Oracle to list the tables, we ran select star from all tables, right? In MySQL, we run show tables. To list the databases in MySQL, we run show databases. If you are familiar with MySQL, in terms of MongoDB, they call it as database and collections. Okay, in one Mongo installation, you can have as many databases as you want. It is a multi-tenant data technology, so you can have multiple databases in one Mongo installation. As you can have multiple databases, to list the databases, you can run the command called show DBS. DB stands for database. Okay, and in MongoDB, they don't use term called table and row. They call it as collection and document. Instead of table and row, we call them as collection and document. Okay, so if you want to list the collections, we should not use tables and rows when it comes to MongoDB. For HBase and Cassandra, the terms might be a bit different. They might call it as table, and they might call it as something else for row. Okay, in HBase, they call it as table and cells. They don't call it as collection and documents there. So you need to understand the terms used to represent certain things depending upon the technology you are exploring. In MongoDB, we call it as collection and document. Collection is nothing but a group of documents. Like table is nothing but a group of rows. Collection is nothing but a group of documents. Okay. So to list the collection databases, you run show DBs. To switch to a database, you can say use retail_db, and then you can run show collections to list the collections. So I have these 7 collections in this. That is correct, Puru. DB in Mongo is schema in Oracle and database in MongoDB. Sorry, in MySQL. In MySQL, MySQL is also multi-tenant database technology. So with one installation of MySQL, you can have as many databases as you want. Whereas in Oracle, you can only have one database up to 11G. In 12C, they are trying to make even Oracle as a multi-tenant database. So up to 11G, you have one database and multiple schemas within the database. So as Puru have mentioned, yes, a DB in Mongo is like a schema in Oracle up to 11G. In 12C, it might change a bit. I'm not sure about 12C because I haven't explored it. Okay. So we have run show DBs and show collections. So there is nothing like create collection. I think there could be. Let me say db dot and hit tab. And it will show all the APIs that are available. Yeah, there is a create collection. but we hardly use create collection to create collections. And one thing you need to keep in mind is, unlike in RDBMS where we have a rigid structure, in NoSQL databases, it can be dynamic. Okay, hence we typically don't create collection with predefined columns. We don't need to do that. Okay, so that's why we call it as flexible schema. All the NoSQL databases support flexible schemas. Okay, either you can use db.create collection, but I don't recommend to use that. So what you can do is you can give a collection name. So I'm saying demo dot. So demo is the collection name, and there is no collection by name demo yet. There are only these 7 collections: customer categories, customers, departments, order items, orders, products, sales, etc. Okay. Now I am creating a collection called demo dot insert. This is how you perform insert. Again, whenever you deal with a database, first thing you should focus is on CRUD operations: create, read, update, and delete. So create is nothing but insert. So now I'm showing you how to insert. Whatever database you start with, it could be MongoDB, it could be RDBMS, it could be MySQL, RDBMS databases like MySQL or Oracle or Postgres, or it could be Teradata, or it could be Greenplum, Vertica. Any technology which is a database technology, you should first understand how the CRUD operations are performed. That is a very good starting point. Okay. So here I'm saying db.demo.insert, and then we have to pass something called JSON. JSON, if you are familiar with XML, is similar to that, and it is represented in curly braces. Okay, so you can see here. In that, we have to pass key and values. Okay, so let me just say employee ID 1. I will come to the question in a moment. Employee name dot tiger. Okay, so you have curly brace, and if you look at the curly brace, we have 2 values which are separated by comma, and each of those values have key and value. Key is EMP-ID, and value is 1 for that EMP-ID, and for the second one, key is employee name and value is Scott Tiger. Okay, if you hit enter, it says n inserted as 1, so insert is successful. So here employee ID and employee name are column names, and I can insert one more record. I will come to those questions in a moment. Just give me few more couple of minutes. I will come back to the questions. Okay, so I'm inserting one more record here, and let me name it as Nina Butcher. Now we have 2 records. Now I'm inserting one more. So in this case, I am saying employee ID instead of EMP underscore ID. I am saying employee ID, and I am saying ename here. And then I am naming it as MLN and hit enter. Even this one is inserted. You can see that we don't need to insert the data with same column names. We can use whatever column name we want. But this is not good practice. Okay, even though it facilitates us, we should be careful. And as we will be using applications to do this, we typically will not end up into these issues. For demo purpose, we can do, but we typically don't insert data like this directly. We typically use applications, and when it comes to applications, we will generate common column name for each and every record while inserting into the table. So it's not a big deal. Now let us see how we can actually see the data. We can say db.demo. Demo is our collection name. If I say show collections now, we will see demo also. Okay. And to see the results, we can say db.demo.find, and then we have to pass curly brace. So in this case, it is like select star from demo where there is no criteria, which means select star from demo. That's it. And you can see the data. If you observe, there is a field called underscore ID, and we haven't inserted that. So whenever you try to insert the data in MongoDB, it will add that field called underscore ID, and it will generate a unique number of type object ID. It is a hexadecimal number, and it will use it for the indexing and partitioning purpose. And if you want, you can replace that with your business value also. It need not be system generated. If you don't use any ID by using underscore ID, if you don't generate by yourself, it will use system ID. Otherwise, you can generate the ID and you can assign it to ID, and that will be used for indexing and partitioning the data, or sorting and partitioning the data. So now let me take these questions before going further. Yeah, there has to be space, Rahul. What is that? No. See here, there has to be space after Mongo. Can you paste the command now? Whatever you are trying. Let me see. You are on GW02, right? Don't worry, I will figure it out. Okay, what mistake you are doing? Sudo su Rahul 2sh 89. Okay, you are not exited yet, so I cannot see what you have done. Can you exit? Exited? It's working. Previously there was typos. I will tell you what are the issues. History. So you see here, you have given Mongo -- host. So there is no space here, and there is no space here. 67, it should have worked for sure. You can try now, it will work. You can just copy paste this and it will work. It's working. Okay. Yeah, it will work. So now let me go back. Yeah, first you have to switch to the database using retail DB. Okay, and then show collections. Okay. So now I am actually saying again db.demo.find, and this is how data is. So if you want to get it a bit well formatted, you can use a command called dot, means you can pass the output to a function called pretty, and the data will be formatted like this. And by default, it will only display 20, and you have to type IT and hit enter to get next 20 records if you have more than 20 records in the collection. Okay. If you just want to get one record, you can say find one, and it will get the first record for you. Okay. If you want to get one record or all the records matching a criteria, what we have to do is we have to say find one. Now we have to apply where condition. So again, recollect the flow which we have spoken when it comes to RDBMS, flow of execution. It works with from clause. First, the from clause will be executed, then where clause. Then if there is group by clause, then having clause, then third clause, then sorting. So here is also we are doing the same thing. We are saying db.demo means we are first reading the data, and then we are applying the filter condition. If we have to aggregate, we have to aggregate using a different approach. We will see those things probably as part of the next class. For now, we'll just focus on filtering. Okay. So in this case, I can say find one, and I can say emp id 2. So I'm trying to get the record related to employee id 2. Okay, and hit enter. You can see here. So find one is to just get one record. If there are multiple records and if you want to display everything, you have to say find instead of find one. So the same thing works with both find and find one. Find one behavior is to just randomly get one record matching the criteria, whereas with find you will get as many records as there are. Okay. So to play with the data, instead of generating some random data, what we can do is we can actually load some existing data and we can play around it. Okay. So for this purpose, I'm creating a new database called retail_db_demo. Okay. So I have created a new database now. When I say use, if there's no database, it will create one for you. Okay. You can validate it by saying show DBs. Okay. I think as there are no collections, it is not showing. Once you create a collection, it will actually show up. Okay. So to get data into a collection in a database, you can use something called Mongo import. But Mongo import is not set up on GW02. So you will not be able to use Mongo import. But administrators, they can use Mongo import on the server where the Mongo is installed. In this case, Mongo is installed on GW01. So I have to connect to GW01 and I can load the data. Okay. So already data is loaded. I will just show you the syntax, how the Mongo import is done. But it is already done in retail_db database, and we have all the 6 tables with data. Okay. So that being said, I am connecting. I am connecting to GW01 now. So this is how it will look like. So if I want to insert into another database, I can just say Mongo import --db retail_db_ whatever database I want. Then the collection name, then the type. Type can be CSV, some delimited file like CSV or TSV or anything, or JSON. You can also import directly from JSON. And I have JSON file for orders in this location /data/retail_db_JSON departments, and this is the file which have the JSON data. So let me show you the data to understand what we have there. I'm using head and I'm pasting this. You can see it's a JSON where each record have column name value, comma separated in curly braces. JSON stands for JavaScript object notation. Okay. So in JavaScript, we represent objects like this with column names and values, comma separated in curly braces like this. Okay. So once we run this, data will be imported. Let me show you. And I'm creating a new DB called demo. Now you see 6 records are imported. Similarly, I'm trying to load. orders data, and there are 680,083 records which are inserted as documents. For now, we are just using a copy of the data which we have in RDBMS tables. But when it comes to documents, they can be nested. So we can actually create a denormalized table between orders and order items, addressing redundancy, where all the order items for a given order can be collection within the same document. I will demonstrate as part of the next class. Okay. So that being said, now if I go to Mongo, and if I go to GW02 and connect to Mongo and say show DBs, we can see this new database called retail_db_demo also. And we have orders and departments, but we have more data than that in retail_db. So why I am showing you about Mongo import is you don't need to struggle to create data for exploratory purposes. You can load comma separated data, TSV separated, tab separated data, or JSON data using Mongo import. So you should use those tools. The way we have used in Apex, where we uploaded orders data and inserted into the table, the same way we can use Mongo import and load the data. You should be familiar with these tools. Okay, you can have MongoDB installed on your PC also. On Windows, it's very easy to install, and then you can actually run Mongo import on your PC also. Okay, now I switch to this retail DB, and we will be focusing on orders data now. Order dot find dot pretty. You can see it actually returned 20 records randomly with object ID, order ID, order date, and order customer ID and order status. I need to check. I need to see whether we want to do that or not. We will try to get it. Otherwise, you can set up MongoDB on your PC. It's very easy to install Mongo on Windows. Okay, we will see. We'll get back to you. So now, let us say I want to get data which is which belong to order ID, order date 2013 July 25th, and then order status closed. So we are trying to do Boolean AND. Okay, where in SQL, how will we write? We will say select all from orders where order date equal to, we will give this date, and order status equal to closed. This is how the query will look like in traditional RDBMS. Now we are trying to write the same query using Mongo query syntax. Mongo uses JSON itself to query. Okay, whatever we are doing is JSON itself. That's why we are putting in curly braces. Okay, so using JSON notation, we have to query in MongoDB. So for Boolean AND, it's very straightforward. We just have to use comma separated conditions, and it will work. With equal, we just have to say colon. It will work. So let me show you. DB dot orders dot find. We have to put it in curly brackets, and then order date like this, and then order status closed. That is order date equal to so and so, and order status equal to closed. So if it is equal, we just have to say like this. But if it is greater than or less than, we cannot use equal, greater than or equal to, less than or equal to, etc. You have to use JSON notation even for that. And we will see example for that also. And hit enter. Now you see the data. If you want to beautify it, you can say pretty. see the results. Okay. Okay. So on Bala's request, we'll stop. Um, Also, I promised you that we will discuss on the queries which are given as exercises yesterday. We will also defer that for now, and we will focus on that as part of Tuesday class. Tuesday, I will wrap up Mongo within 1 hour, and last 1 hour or 1 hour 15 minutes. Last 15-20 minutes, we will focus on the exercises which I have given yesterday. And also make sure you set up the development environment for Scala so that starting from second class next week, we can focus on Scala using IntelliJ as IDE. It's better for you to become comfortable with IntelliJ as much as possible. Hence, make sure you set up the environment as asked in the document. Okay. That being said, before we close today, if you stuck in while setting up the environment, use discuss.itversity.com and start writing the issues over there. And I will ask my support team to get back to you immediately. Also, those who are interested within you guys also can support each other and make sure the issues are closed. That being said, Prithvi, we will talk about it on Tuesday's class. Okay, so don't worry too much about it. I will cover several of those scenarios, and also I will give some exercises also on MongoDB. Okay. Any questions before we wrap up today? And thank you for everyone who joined on YouTube. This is just to show how the training goes on. If you are interested, you can follow us on LinkedIn or any other social networking platform, and we'll be broadcasting the message if we conduct any live classes like this, or if we come up with self-paced content. If you are interested, you can sign up. Yeah, Shiva, I will send those details. So when it comes to Mac, you can follow the same document, but you have to ignore certain videos, and I will highlight what can be ignored in the same document. So I will update the document by end of the day today. Then you will have instructions what can be ignored. Masood, there is no class tomorrow. The next class is on Monday night US time or Tuesday morning India time. Kumar is asking, is saying NoSQL DBs are not meant for reporting need. No, you can use NoSQL databases for reporting also. Okay. We will understand that as we proceed further. So in this case, if you look at the LinkedIn, it is a report which you are seeing, and it is fetched from NoSQL database only. Okay. But NoSQL is not meant for transactional based use cases. You should not use NoSQL for transaction based mission critical systems like e-commerce platforms, banking platforms, etc., where money transactions are involved. Okay, then. Any other question? I will wait for another minute. If there are no questions in next 15 seconds, I will wrap up. Otherwise, I will wait until I get questions. I can take few more questions today. So again, for those YouTube guys, this is middle of our training under the name of Data Engineering Bootcamp, where we are covering many technologies starting from Linux fundamentals, database essentials. This is the last topic as part of database essentials. Then we are going to cover big data after covering Scala and Python as programming languages and many other technologies. The program goes for 4 to 5 months, and I typically stream the videos for backup for my live audience. But in this case, I'm just opening up to the public so that you guys understand how the training goes. That being said, as there are no more questions, we will wrap up for today. Thank you. Bye.